Thank you.
Okay, so what I want to do is just run through a little bit of the history of how we got to start developing defensive challenge labs and what the challenges were in developing those labs, and then talk a little bit more about where we're going from that point in the future. And we'll kind of break it into four sections. Context for cybersecurity training, what the context was for developing our defensive training, trying harder with penetration testing and what that really meant for the defensive side, building defensive challenge labs, and the evolution to Kali Purple.
Oh, that's me, Kali Purple. Here we go. The thing is, for Kali Purple, we're going to have a bit of a demonstration later on. I need your help for that one, though. Yeah, because Kali Purple is all about SIEM, SOC, IDS, IPS, firewalls, everything, the whole shebang. So what I would like you to do, all the people here, the hackers with a laptop, are there any left? Or have they left already? If anyone is here with a laptop or a NetHunter phone, that's even better, with a NetHunter phone, if you could connect to the Wi-Fi network Kali Purple WAN with the password syncon reloaded, and then just be noisy, yeah, because that is the Wi-Fi network connected to the WAN interface of our Kali Purple instance that we've got running out there at our booth. Be noisy, do an Nmap scan, do a Nessus scan, whatever you want to do. The only thing is, because there are going to be hopefully several of you trying to break into the vulnerable machine, I give you the IP address so that you don't hack yourselves. Yes, so there is an IP address ending with the 111, 111. 111 is the web server that exposes a web interface that is very vulnerable. So you can just go crazy and just have fun with it. And then at the end, towards the end of the presentation, we're going to have a look at what it created in the Kali Purple instance in our IDS's IPS. And the same. Over to you.
Thank you, Carsten. Okay, so let's get started with the context for cybersecurity training. So what is the context that we kind of came from that really set us up to thinking about how we do that training? And the context really kind of started last century, which kind of sounds strange, but hacking as a cult with the Legion of Doom and Masters of Deception. 1986, there's the first password hacking tool. Kind of interesting to think 35 years later, password hacking tools are still breaking into systems. Haven't really kind of progressed very much since then. Kevin Mitnick was one of the heroes of the day, and on the defensive side, we created ISO 27000 and SP 853. Clifford Stoll with the Cuckoo's Egg kind of showed us a little bit of the fact that cyber, in those days even, was not just about kids playing, it was about cyber espionage. And the Black Hat Conference started in 1997. So coming forward to this century, the internet use is growing exponentially. The EC Council starts its CEH program. The rootkits book was published. Now everybody knows how to write rootkits. And hacking tools start to appear. WOX, Auditor Security Collection, and Metasploit. So we've got tools starting to appear on the offensive security side. We've got guidance in the form of rootkits and training courses. And penetration testing became an established career. 2005 to 2010, kind of moved to the next stage, and we got Estonia suffering a cyber warfare attack. Evolution of testing tools. So we started seeing some more powerful tools coming out. And OSCP and CREST certifications started in 2006. CREST and Offensive Security started in 2006. And of course, we have got ISO 27000 and SP 853, so we don't need to do anything more, we just kind of keep using them. So defensive security didn't really kind of do a great deal other than issue another version of a standard on the day. Cyber attacks get serious, we start getting Zeus and botnets appearing and cybercrime starting to happen at scale. Nation-state attacks with Stuxnet being a popular example. Snowden released a lot of NSA tools, which was great because he gave all the bad guys all the really advanced techniques that the US and its allies had been developing. So that's really good. But defense started to wake up, and we started to get things like the MITRE ATT&CK platform, created in 2013. So we're starting to see a little bit more context around defense actually might be almost as important as offensive security. And NIST released its cybersecurity framework, so finally we get something that's more suited to cyber than the traditional standards. And offensive security releases Kali Linux. And we get advanced online hacking sites, some of the really good online capabilities for trainee hackers and hackers who want to kind of keep going with more advanced boxes to go on and use them. The offensive security playgrounds, HackTheBox in Europe. So teaching for defensive security, what are we doing? What were we doing then? What are we doing now in teaching for defensive security? Well, we're putting people through graduate programs or postgraduate programs in information security or information assurance, as it was for a while. More recently, cybersecurity. The postgrad and the graduate programs really are, in many ways, quite theoretical rather than hands-on. We have specialist certifications, CISSP, 27,000 auditor. 27,000 is very sticky. It's very hard to move away from. PCI DSS, and so on. And mostly what we're doing is book learning, multi-choice or written answer examinations. Also, kind of round about 2015-ish, in the UK, a new program was issued, which was created, which was the Torch program. And the Torch program was moving cybersecurity training out to polytechs. In Australia, we followed that up a year later, and we created the Australian Certificate 4 in Cybersecurity for the TAFE system in Australia. That's been quite successful. It's hands-on vocational pen testing, hands-on SOC analysis. It's a 10-month course where people come out of the course and they have the skills to do the job. At the moment, through the Cert 4 in Australia, last year, there were 5,000 people graduated. So this was a big step forward from the universities, being able to graduate 5,000 people with practical skills that can go straight into organisations and work productively after 10 months. So that's kind of where we came from and where we've got to in the formal side of how do we train people and what are we training them for. But when we look at what we've done at Offensive Security with the kind of try-harder mindset, and CREST as well with its approach, is a little bit different. So Backtrack became Kali Linux. Exploit DB provides threat intelligence so that exploit intelligence so that there are exploits that can be downloaded and used to practice. VulnHub offers vulnerable machines. OSCP becomes a leading pen testing certification. And bug learning shifts to hands-on training and a hands-on exam with a try-harder mindset of, if you can't do it when you first go to try the problem, you're not going to get a great deal of sympathy from your trainers until you've really tried harder. And it's difficult to obtain an OSCP, and I'm sure those of you that have got it would agree to that, would attest to that. But it drives respect. If you've got an OSCP, you can do pen testing. If I'm a CISO, if I want a pen test and I've got someone with an OSCP, I'm going to be reasonably confident I can get a good pen test from them. So that's a good place to be in the offensive cybersecurity space. In offensive cybersecurity, we have an online portal for vulnerable machines. The playground, proving grounds. Kali is a testing workstation. The PWK course provided a lot of targets and subnets that you could move into to practice going through, tunnels to practice lateral movement. And at the end of it, when you do your exam, there's a 24-hour skill-based exam. You need to have the skills to get through that exam. It's the proving grounds. That's evolved with additional qualifications such as the OSCE, OSWE. Pen 100 was introduced as a platform for starting to come from a low level of knowledge through to a level of knowledge where you could actually pick up an OSCP training course and go through that and get your qualification. PWK became Pen 200. And there are additional 200 and 300 level courses that have been and are being developed in the pen testing series. And that's the topics in the Pen 200 qualification. So the offensive training is developing and evolving and becoming more capable to produce more capable pen testers. So how do we apply the experience that we gained from developing OSCP to deliver the same thing on the defensive side? How do I get to the point where I can say to someone, I've got a problem. I want you to protect my business. And I can trust that you can do that because you've got that certification. I know that means that you've got the skills. So how do we do that? How do we make that equivalence? So the first thing is a solid foundational knowledge on the 100 level, which we can do through the 100 series courses that the pen testers take because a lot of them overlap. And there are specialist defensive ones. Deep learning through 200 level special focus courses. It's a little bit different because on the defensive side, we're not talking one skill set, we're talking multiple skill sets. So we're talking SOC analysts, we're talking system administrators, cloud administrators, web administrators. And there's a little bit more width to the whole space. The introduction of the OSDA is moving in that direction and has started to deliver some of the capability that we're looking for, with the SOC 200 being the first cab off the rank in OSDA. The OSDA training course is a hands-on practical training course, and there are challenge labs to go with it that you can separately go into a challenge lab and practice. And that whole approach is really trying to reflect the OSCP approach of demonstrable skills. Just kind of a slight just kind of picking up offensive and defensive and looking at what they are. The offensive teaching is a vulnerable system that you learn to break into, using tools to enumerate, gain foothold, get user, get root, extract flags. And you need to win once. You need to get there and get that flag once. On the defensive side, you've got assets that need protecting. You have to identify them. You have to protect them. You have to detect the attacks that are coming in. You have to respond to them and recover from them. And you need to win every time. So it's a slightly different approach that we have to look at a different way of doing it and slightly different approaches to the challenge labs. So if we take the focus area of security operations as the first cab off the rank for SOC 200 OSDA, the objective is to teach SOC analysts how to detect attacks. And the challenges for that is scaling for the challenge labs. When I go in to do a pen testing test, when I want to use a system on a proving ground, I can go in and work against one machine. When I want to get a challenge lab for defense, I've got to provision 4 or 5 machines, or in fact in some of the bigger labs up to 15 machines. So that's a scaling problem because we're not scaling just 1 system per student, but 15 systems per student. We have the problem where in the pen testing space, there are a lot of open source tools that are used. And even if they're licensed tools like Burp Suite, there is an open source community version. But what do we do for defensive? Because most of the tools are actually commercial tools. So do we use Splunk? Do we pay a license for Splunk and teach Splunk? Or do we use ElkStack, which is open source? And that's a question. It's an open question of how do we handle that. Automating real attacks. If you're going to do defensive, if you're going to do a pen test training, a vulnerable machine will be put up. And you can then, as a pen tester, as a student, go against that machine. The machine just sits there and waits for you to do that. There's nothing else it needs to do. When you're doing the defensive challenges, you're sitting there on a machine, monitoring what's happening, and something has to mount an attack on you. So all of a sudden, we've now got to automate, and preferably automate real attacks, not just create things that are not realistic. So the approach we've taken is to use the ElkStack seam. We are also doing development of training material for Splunk and for Greylog and other tools as well. But at the moment, the challenge labs use ElkStack. We use an Nginx proxy and website, Suricata IDS. We've got Snort IDS in some of the challenge labs, but Suricata is really the preference. And we're using scripted attacks, so everything has to be automated using Python, and we're using tools, libraries like the Paramiko library for SSH access and so on. So the challenge lab 8.5, we have 15 labs in SOC 200. This is one that we've created which is kind of round about the middle of the lab space. And you can see that consists of a Kali attack workstation going through a Snort IDS. The student connects in through an Nginx proxy. And there's Active Directory running, a CentOS website, a Windows server, a Linux Ubuntu server, and the Elk seam. So that's a reasonable collection of machines to launch. The student, from a student perspective, sees the Elk log discovery screen. So what did we learn by developing some of these challenge labs? Getting ElkStack built reliably takes time. And one of the problems is once you know how to do it, and you've done it a dozen times, you can do it again. But doing it the first time, there are so many ways you can make mistakes that it really gets quite difficult. So we have spent a lot of time just trying to get the scripting for building things like Elk to a reliable state. Relatively straightforward when you do an insecure build, but as soon as you start securing it and have to deal with certificates and getting agents to talk through secure channels, it just introduces problems. It shouldn't, but it does in practice. And it's easy to get problems with different versions of the agents and the main Elk system. And one of the other issues with the versions is if you want to integrate a particular kind of log, you might need a particular level of Elk to do it. So it gets challenging just kind of keeping all that in line. We found that getting Elk agents to connect to Fleet was a particular pain point, which in the end went away because we knew how to do it properly and it worked. But for a long time we were battling with agents just stopping talking. And all sorts of kind of interesting things, like when we start up, Elk would start up and crash. And we'd go in, okay, so Kibana's running, Elastic isn't. Close down Kibana, start up Elastic, starts up perfectly, start up Kibana, starts up perfectly. What's the problem? Why didn't it start? Well, it turns out there's a slightly hidden timeout equals 75 seconds in one of the configuration files. And because of the startup, we weren't starting up in that time, and we were just tickling over 75 seconds, but not all the time. And things like that just take time to build experience up on how to get it running. Managing Elk logs was another pain point. We weren't using Logstash, and because we were launching virtual machines and trying to keep them tight and small, it was kind of tempting to keep the disk space small. And of course what that meant was that Elk logs just filled all the disk and basically killed the system, and we ended up having to wipe it and restart. So managing those was another pain point. Again, everything's easy when you know. What was easy was getting logs from Windows, which we thought would be difficult, but Sysmon running on there just gave us a good source. But I think the other thing that we kind of came to at the end is that this is a good point, but it's not the end point, because Elk, or Seam, isn't the only tool in the SOC toolkit. So it's only part of the story, and we've got other things we have to do. So developing with isolated subnets was a challenge. We wanted subnets where you couldn't get into the subnet without going through some form of tunnel. We could develop that in the development environment. As soon as we moved it to pre-prod to test it, the challenge lab just stopped working. And there were hidden places where things were wanting to connect to the internet that we didn't know about. We had problems with vSphere not allowing us to go into promiscuous mode, which was kind of a problem for our IDS, which we ended up having to kind of work around. And it was just because the particular environment we had in AWS didn't allow us to do that. Dynamic IP addresses. We are launching new servers in the same space for different students, and they've got different IP addresses. We've got attacks trying to attack across a set of machines, and we need to coordinate those IP addresses so that we get the right ones. Attack automation takes time. You've got to make the target vulnerable, then you've got to build the exploit, and you've got to script the automation. You've got to identify the detection logs, because actually what you're doing is teaching someone to detect it. And lateral movements and managing lateral movements through tunnels when you're automating can be quite hard. So this is just some of the kind of snippets of the stuff we've been doing. With the boot up service, having to wait to get its IP address provisioned, and then using that to change configuration files and restart services. Simple things like code at the bottom of a website was starting to cause the websites just to stutter for a reasonable length of time while it timed out trying to connect to the internet. We ended up taking some of the websites and taking out code like that. Turns out that when you use Elasticsearch, you've got to give it an internet access to the Elastic Package Registry. That's a problem because we didn't have internet access. So we ended up having to install EPR on the ELK server with as a Docker image. Managing access was fine. It was just lots of different ways we had to work with it. curl with websites, Paramiko for SSH. We use Paramiko proxy for lateral access and Netcat and SSH tunnels. We used command libraries for shells. We couldn't just issue an OS system command and get a shell back. So we had to use the shell spawn and receive, and then we could issue the commands on that. So they're just some kind of examples of the way we code in parts of our exploits. So the learnings, overall, building a cyber defense lab is fairly hard. Open source tools can be problematic, at least to start. Cyber attacks are multi-stage. So we didn't want to have something that went all the way through from initial touch to complete root. We wanted to stop after reconnaissance, go to a second stage, go to a third stage, and let the student who's doing the discovery take it in digestible bites, really. We had to build and run multiple VMs for each of the labs. Synchronizing addresses can be tricky, and automating attacks does require a reasonable amount of work. The kind of attacks we're doing: SQL map injections, directory traversal, kernel exploitation, PowerShell password spraying, PowerShell attacks on services, and so on. So these are just kind of some of the examples of the techniques used. Fortunately, we are a very well-served company, so when we're developing these kind of attacks, we don't need to do all the work ourselves. We have people who are specialists, for instance, in malware. One of the attacks in one of the labs needed some malware for a mail attack, a mail attachment attack. And we had someone who could actually build that malware for us, which is good. I just want to finish my part of this with just a quick look at Linux. Obviously, that's the attack platform we use in the challenge labs, and it comes as a distro and a VM, so we can load it and use it like that. It's also built for as NetHunter. It's Kali in the browser now. It's not just a standalone workstation. So the training allows the use of Kali in the browser. The PinePhone build with a command line is a Kali platform. And Carsten's latest project was, prior to Kali Purple, was a smartwatch build. And that kind of brings me on to an evolution to Kali Purple and the question of, what is this purple thing? And at that point, I'd like to hand over to Carsten.
Thank you. Thanks very much. And also thank you to the busy ones amongst you. I can see you have been busy. Yes, so there are some of you that have gone wild on the WAN interface of our DMZ. So the thing is that when Malcolm and I had a discussion about the setup of the challenge labs and the challenges they had to set up the challenge labs, I remembered I had the same challenges when I had to set up the Elastic Stack, a SIEM environment myself. We had to go through Every pain point that he listed, we had to go through ourselves. The problem that I then saw was, once we finished the $1 million investment in a SIEM infrastructure for a large corporation, everybody was too afraid to ever touch it again. And that's the problem that we have in the defensive space, is that once you invest in technology, you probably have forgotten to ask for a little bit of spare money to then invest in development environments, quality environments, training environments, environments that people can just play around and then develop a conceptual understanding, a deep conceptual understanding of how this all works. And that's what I then realized when Malcolm told me about all the problems that they were facing. So let me just try to get this up. Here we go. Is that coming? There you go. So, let me just go through a couple of slides, and I don't want to bore you for too long. Here we go. So basically, what is Kali Purple? Kali Purple is a sock in a box. So the thing is, Kali is not a penetration testing operating system. Kali is an operating system. It's colorblind. It doesn't care what you do with it. It is just that we were biased when we created Kali towards packaging up tools and software that are made for offensive tasks. But we said, well, we can do exactly the same for defensive tasks as well. And this is now something where the offensive people, the penetration testers amongst you, you were spoiled. Straight from university, you could download a Kali image, you can install it as a VM, you install a vulnerable machine, you spend a couple of months practicing, you did an OSCP course, you got your OSCP certification, and then you got a job that usually people asked for 5 to 10 years of experience. And you had no experience because you actually did have experience. You developed the contextual knowledge purely by downloading stuff, playing around, and satisfying your own curiosity. That was not available for defensive, or very hard to make the same available for defensive. And now we decided, why don't we do exactly the same? So what we did was, we packaged up software that is meant for defensive use, SIEMs. We already had vulnerability scanners, etc. But we packaged it all up, and we are still packaging it up. So we haven't fully released it yet. We're just putting it out there for you to contribute, to tell us what works, what doesn't work, what would you like to have to play around with to bring up your skills in defensive stuff. Yeah? And that is, it starts with who's ever played with SD-LANs? Who's ever played with Type 1 hypervisors? Who's ever played with, with firewalls, IDSs, IPSs, the ELK stack that corporations spent $1 million for implementing, etc., with threat hunting tools, etc. That one contains it all. So what you can do is you can pick and choose what you would like to practice, you install it, and then you have a go. And you can use it for blue, red, purple teaming. So if you prefer blue, if you prefer red, it doesn't matter. Yeah? With purple, you can do everything. You can do a pen test, and then you can see what it will end up in the log files of your IDS. You can see what it will end up in the dashboards of your SIEM. So that's what it is. Now that one is a little bit small. Basically what it highlights is that Kali Purple consists of various VMs. Each of them is named after a shade of purple. Very hard to pronounce, sorry for that. So what we've got basically, we have got a OpenSense firewall, which is running Suricata, IDS, IPS. It's running Nginx, it's running WEF, Nginx WEF. It's running DNS forwarders. It's running everything you need for a proper firewall. We've got Kali Purple VM, which is running the SIEM, the Elastic stack. It's also running OpenVAS vulnerability management. We've got Kali Eminence, which is the threat hunting platform. So that's what we can use. We've got Alchemy running on it, etc. That's what you can use to practice threat hunting. And what we're also going to do is, Malcolm is working on that one, is also releasing scripts. So if you are not really into the offensive side, we provide scripts that you can run to then simulate attacks on your DMZ environment so that you can practice. You can practice to tune your rules. You can practice all these things that large corporations, I must admit, can't do because they don't have those development environments to just play around to do these things. Who would like to play around with rules in the production environment? No one. So therefore, the people, the SOC analysts these days, they are very good developing procedural knowledge, applying the standards and the procedures that have previously been developed for them, but they can't really take it anywhere because they don't have the playground to develop a conceptual understanding of what is underneath and really questioning what has been set up. With this one, you can do it in your own living room. So basically, it's very modular. As I said, Kali Purple is nothing else but us providing software that you can choose to install or not to install, depending on your own preferences. So what we've got is Byzantium is a firewall, WAF, IDS, IPS. We've got Heliotrope, which is a Linux client that you can use to run penetration tests on your DMZ or internally, whatever you want to do with it. Kali Purple is the actual theme, the Elastic Stack and the vulnerability scanner. I'm running out of time, so let's just go through it. And then we've got Eminence, which is for threat hunting. And then we've got a vulnerable machine or several vulnerable machines in your DMZ. And it is enterprise-grade technology. So basically, what we have installed on Kali Purple has been installed by large corporations. They have invested millions of dollars in it. And you can install it on a $200 PC in your own living room and play around with it and have and practice. And that's, for example, that's what we've got installed in our own living rooms. It's either a NUC or a little firewall appliance of AliExpress for $200. And you can see it out at the offensive security booth. You can see the NUC that is running what I'm going to show you now. It's running the entire stack, and it's just a $500 NUC. It is for blue, red, and purple teaming. Basically, for blue teamers, you can tweak the rules until they are perfect. Yeah, there's a little spelling mistake. You can observe the traces. As a red teamer, you can then do a penetration test and then observe the traces you leave behind. And then you can improve your own stealth in your penetration tests. And blue and red teams exploring cause and effect together to achieve better security. Yes, so you can then get a penetration test. If you are on the blue side, you can get a penetration tester in, and then you can sit them in front of your development environment, your Kali Purple box, and you can then ask them to go wild against your DMZ. And then when you see something that you didn't really catch in your rules, you can say, stop there. Now let me try something. Now do that again. And then you can tweak your rules, and you can develop an understanding of what's really going on, cause and effect. It's inexpensive lab for home. It's great training environment for companies. It's scalable development environment and perfect for low-budget production environments. So I've actually installed it. I've deployed it for low-budget production environments. And it's the same underlying concept that corporations pay millions of dollars for. And most importantly, it is by hackers for hackers. It is a community project. So we have just put it out there. We've shown what is possible. Nothing is set in stone, so we haven't developed a strategy and said, this is what we are trying to achieve. So if you come back to us and you can contribute, commit to our GitLab repository, and if you want to take the whole project in a different direction, well, let's just go with it. Yeah, so I really encourage you to help out with it. But let me actually show you what it looks like. So basically what we've got is, we've got a cheap computer with a type 1 hypervisor that is free, it's Proxmox. We installed a couple of virtual machines. One is the firewall, which is running here. And the firewall is running a couple of, it's an open sense firewall. It's running a couple of services, including Suricata, IDS, IPS. It's unbound DNS forwarder. It's running Nginx and its web application firewall, etc. And everything is configured to then forward the log files to Elastic. Elastic is then running on this one here, which is the Kali Purple machine. And let's have a look at the Elastic. So that's what the Elastic looks like. And we can see something has happened when people try to do something. So let's have a look at the... So these are the firewall logs that have been forwarded from the firewall. We can now tweak the rules, make things a little bit easier. But the whole point of this one is that what you are seeing here, I don't know how many people you have ever worked with Elastic Seam. Hands up. Yeah, there's one. There's not many people around, but Elastic, yeah, there are a few more people. Or how many people have worked with Splunk? Yeah, there are a few more people. How many people would like to get their hands dirty with it? So that when they go into an interview and being asked, have you ever worked with Splunk? Yes. Have you ever worked with Elastic? Worked with it. I've installed it 100 times. That's the thing, and that's the thing. Yeah? So you can install it 100 times, you can take it apart, install it again. So this is now what happened when you try to hack the web application, our DMZ. Yeah, so that was where our web application firewall got a little bit cranky when you tried to do a SQL Server injection. These are the firewall logs. What we also had, so this is the Kali Purple box, which is the seam. So basically, what we're going to do is we are currently working on packaging up not the seam itself, which has been packaged up by Elastic. What we are packaging up is an installer. Because the important part is, as I said, is to gain conceptual knowledge of the installation. You have to install it. So what happens is we're going to package up an installer. All you're going to do is you're going to run apt install. I think we're going to call it Kali Elastic Installer. And that one then installs the main components also. It amends your sources list, etc. And then, so it starts everything. All you then have to do is you then have to run the installer locally and say, for example, Kali Elastic Installer 1 or Setup 1. That one then helps you to set up your certificates, your encryption keys, etc. So you know what's going on in the background, yeah? And then you have a Setup 2, which then completes the installation, and then your seam is set up, completely set up. Yeah? And that is the seam part. It will install your OpenVAS vulnerability scanner as well. And then we get to Malcolm. Has anyone ever heard of Malcolm? Yeah, one? No, that's it. So has anyone heard of Alchemy? Alchemy, yeah, a few people of Alchemy. So basically, Malcolm is Alchemy on steroids. So it's basically a bunch of threat hunting packages dockered up. It's just easier to install. And that's what we went with. So we went with, on Kali Eminence, we just installed Malcolm, which has been created by CISA, is it, in the US? I think it was...
CISA and Homeland Security.
Oh, yes. Yeah. So it comes with a nice documentation and a lot of threat hunting components. So all you then have to do is go through the documentation, run Alchemy CyberChef. Anyone here use CyberChef? So it's all there. So basically, your SOC in a box. Yeah, somebody called it on the internet when we said we're going to release it. Somebody said, "Oh, it's just a, what was it? It's a messy collection of tools." Of course it is. That's what it's supposed to be. Yeah, it's like a furniture store. Yeah, when you walk inside, it's made. Of course. Who's got 50 couches at home in the living room? No one, because we sell it. You buy the one that's right for you. The same with Kali Purple. So Kali Purple is we provide everything that most of the people would ever ask for, but they would only ask for parts of it, and it's there for you to use, to learn, but also to have as a training, as a development environment, etc., to get your own skill set up, but also for corporations to have a playground for their defensive people. So basically, what we want to do is, there's now Malcolm dashboards. So what we want to do is, we want to get the level of curiosity, and we want to increase the level of curiosity in the defensive workforce and decrease the level of fear, that people don't have to fear playing around anymore because they're not playing around with a $2 million live production environment. They're playing around with $200 NUC sitting there. And they can just wipe it out, they can reinstall it, and then they can develop a conceptual understanding of what is required in the infrastructure sense, what is required to secure enterprises. And that's what you can set up in your living room at home. So that's Kali Purple for you. Thanks very much for having me, and thanks to the organizers for this amazing conference. Thank you, and thanks for you for having us. Thanks very much.
Are there any questions for Malcolm and Carsten?
I can just encourage you to give it a try. Go to the GitLab page in the Kali. Are we making the presentations available?
Yeah, this is recorded.
Oh, okay, awesome. So you've got the link to the GitLab project. Have a look at that one and contribute, download it, give it a try. Currently, the aim is in March at the next Kali release to have an installer for Kali Purple. An installer will set up, you can then pick the machine you would like to install, and it will set up the machine. That makes it easier for you to complete the setup. The idea is to have it on what we did here on a type 1 hypervisor. Yep. So instead of now paying for VMware licenses, you just install Proxmox, but if there is a demand to install it on VirtualBox or so, on a type 2 hypervisor, just let us know. Yeah? So that's the thing. We put it out there. Nothing has been set in stone. Yeah? It's basically, it's up to the feedback of the community what that one's going to end up as. Yeah? I hope that helped.
Hi.
Thanks very much.
One question here is, would this be available, the Kali Purple will be available for public cloud deployments? Definitely there will be a lot of users would like to try to run it in a public cloud within a containerized environment and try to work on it. Is there any plan for that? Or it still be type 1 hypervised environment?
I don't see any reasons why we can't do that. A thing is now also that some of the tools like Alchemy or CyberChef, for example, they're very, very hard to package up. They're a pain in the neck to package up. So what we might want to do is, and we are currently looking into, you might not have heard of Carboxer. Carboxer is it's similar to a snap package of Ubuntu or so. It's basically a Docker package. So now that we are seriously looking into using Carboxer for Alchemy, for CyberChef, so basically we are already using Docker images for that one there. We might as well then continue down the path. We've got some of the Elasticstack are run in Docker images, so we might as well say, well, we might as well now embrace containerization over type 1 hypervisors. It is just whatever interest there is in the community for us to do. Yeah, so we can, the sky's the limit, we can do anything. It's just that you have to tell us what it is you want us to do. Plus, if you are interested in helping us out, being part of the developer community, just do it yourself and push merge requests up to our GitLab repo. Does that answer your question?
Yep, thanks.
Over time, sorry.
I think we'll take one more question.
One more, yeah.
No question.
And basically, I think if there's interest, so we've got at the OffSec booth over there, you can have a look at the tiny NUC that is running the whole thing. Yeah, If you've got a laptop, I can get you access to the LAN Wi-Fi interface, so you can play with the whole thing yourself. And if there's interest, I can also fire it up tomorrow during the conference. So just see me at the OffSec booth, and then you can just play around with it yourself.
Hi, thank you. Thanks for sharing the tool. It's amazing. Just a question. So the strategy seems to be a sock in the box, right? But you know, I guess from my perspective, I would like to see also perhaps a way of doing it to deploy it in the cloud by Terraform to a scale, right? Because for example, we have a large team, and I want my team not to run it in their computers, but have an actual purple lab, right? We actually, at the moment, we use Detection Lab, right? And we kind of tweak that Terraform to use and add these new tools. And just wondering if that's something perhaps Kali can also just, because it's different strategy, right? Either you run at sock in the box, which is good for the starter, but at the end of the day, perhaps if you want to scale this up and have a large team use this tool together and learn, and like you said, you know, it's very important that the team learns how the whole SIEM and the logs and the attack happens. I can see that perhaps in the pushing that to the cloud, whether you code it in Terraform, you can push it into your laptop if you have a powerful laptop, or you can push it into the cloud, or you can push it into Azure, right? So Terraform or some sort of CI pipeline, right?
I reckon that is an awesome idea. And thanks for that. We should actually write it down. Oh, no, it's on video, right? It's awesome, so I can watch it later. Because these are not the things it's very, very valuable for us.
Yeah.
What we are trying to do also is, and now I'm going to get a little bit ambitious, the next step before we go down that path, the next step is we would like to hit the conference, sorry, just a few more minutes. So we're going to hit a couple of conferences this year to do a spy versus spy. Who knows, who remembers the spy versus spy from the Mad magazine? It's the older ones of us, okay. So we're going to have spy versus spy competitions, yeah, where we're going to have a blue team versus a red team. So the blue team will get, when the competition starts, it's going to be 5 or 8 hours or so. When the competition starts, the blue team will get results from vulnerability scans. They will get the topology diagrams, all the documentations of the environment. The red team will be able to start doing the Nmap scans and everything they want to do. The red team has to collect all the flags. The blue team has to make sure they can't do it. The one thing is, because for the blue team, it's much easier. All they have to do is turn everything off. No, you can't do that. So there are going to be 2 rules. The first rule is the blue team must not impede availability by more than 10 seconds every 10 minutes or so. We haven't decided yet. But they're not allowed to turn anything off. Plus, they're not allowed to download any rules. So they have to analyze what they see, what the red team is doing, and then they have to respond to that and write their own rules. So that's the first thing we're going to do. Once we can pull that off, when we hit the con circuit this year, if we can pull that off, we would like to then work with consultancies, integrators, etc., for them to use that concept to build up their own training environments. For them to then help us to go down the path, go to cloud and go to other things. Because once we enable them, the thing is, we are doing it not for commercial purposes at all. Yeah, we just want to use what we've got. We want to use Kali, yeah, to just help people to use it for something else. If we can pull that off, and if we can establish that in such a way that it helps integrators, it helps consultancies to come up with their own thing, then we would like to push it to the cloud. We would like to then explore containerizations and any other things. Does that make sense?
That makes sense, thanks.
Thanks very much for that input. That was really good. All right, so sorry.
Can we put our hands together to give another round of applause to Malcolm and Carsten?
Thanks very much.